the gold in the lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex, quantum theories on deck, breaking all the specs, relativity theories, worlds getting small, grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep, grafing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold, brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice.
All right, what's up, everybody? Let's start the stage. Yes, Discord, you want to work today? Oh dear, Discord. Okay. There we go. Okay, cool. What's up, everybody? It is Thursday. And Don's here too?
That's dope.
That's dope, Don. What's up, Don? Big shout out to the Don Father. Don Factorial. Nice. Welcome, everyone. Love it, love it. And X-Man's here too.
Good job.
What are you guys doing on your stream, Don? Homework, getting ready for grad school, things that are due. It's always something. I mean, I almost like kind of miss it being in school and having assignments and like deadlines that weren't set by myself. It's kind of a problem when you have to set your own deadlines. I don't know. It's difficult. I set a deadline to put out some videos, some little tutorial videos for what was it? Volumes of Revolution. Don says I was doing some reading on math pedagogy. Oh, okay, cool. I've had a couple questions from chat with linear algebra and orthogonal spaces. Linear algebra, I've slowly been getting better at. Hey, I like this guy. I like you too, Eric. What's up? Yeah, it is scary when you have to come up with your own deadlines. I say it's good practice for how the real world works, especially in like startup land. You have to like do shit yourself. But for instance, one of my like setting deadlines for myself is I wanted to put out more videos this year with like tutorial things, because this is like planting the seeds of content generation stuff. I'll show you guys on like YouTube what I mean by. So, for instance, some of the content that like I posted 4 years ago is only starting to like really catch on now. So, putting out useful, helpful videos such as this is kind of like planting a tree that won't immediately grow, but eventually it, can turn into like cool stuff. Let me see, where's my analytics? I'll show you guys my analytics. If you want to load today, there we go. Okay, cool. So yeah, there we go. This one seems to be doing pretty well. Quick trick for finding horizontal asymptotes. If I like go to this video and look at the analytics, right? It's really been doing like fuck all for the first 2 years it was released, right? I released this back, when was this video released? December 19th, 2022, right? And it's not until, I guess, July of 2024 that it really started, like, taking off. And now it's up to, like, 130,000 views. So this is one of those things where, again, yeah, I posted this 4 years ago almost. I guess 3, technically. Three and some change. And, I mean, so far it's made me $4.92. But anyways, a lot of subscribers. This is cool. So, just, you know, heads up. I know a lot of the younger kids watching, and I find this anytime I go to any sort of community event and they introduce me as, like, an educational influencer. All the kids come up to me like, oh, I want to be a YouTuber. I want to do this. I want to do this. I'm like, yeah. It's cool. But it's a lot of not seeing any fruits of your labors for quite a while.
Yeah.
You're not going to get any results for a while. Yeah. What's up, Shaq? Good to see you.
What's good, Gold? How you doing, bro?
I'm great, dude. I got a haircut today. I got a little beard trim. I got my beard trimmed a little bit.
I see. You don't look like that.
I know. I'm getting rid of the Muhammad look, they say.
Is that
racist?
targeted towards me?
No. Let's see. You were streaming today too, Shaq, right? Yeah?
Yeah, I was streaming for a bit, yeah.
Yeah. So another example of, like, you just gotta, like, keep putting stuff out. Yes, YouTube videos are an investment in the future. Exactly, right? And so last year, I kind of stopped making those tutorials completely because streaming was getting very intense. We were really blowing up with the streams. So this year, one of my New Year's resolutions was put out 2 videos every month. 2, like, short videos, short form videos. So that I at least stockpile that, so 4 years in the future, those can start to catch. So ironically, your video on horizontal asymptotes isn't plateauing. Oh, Jeff, that was a good one. Jeff, you gotta laugh. That was great, Jeff. Wow, Jeff. I thought it was good. Okay, anyways, yeah. So, yes, very true. So keep putting content out. So yeah, I put out. That's my, like, self-imposed deadline this week was to put out these 2 videos. Where are they? They'll load at some point. Yeah. On Volumes of Revolution. I just put this one out today. Now let's make things slightly harder. I put, like, some, you guys had to put the fa, like sound bit in it, so I did. I put it there. But it's a cool little video showing how Volumes of Revolution works, and I still have 2 other parts I want to release. One is where you have to, like, subtract the y coordinate, and then the other one is where the axis of rotation is on the x equals, like, it's a vertical one. So, and then people are asking me to do the shell method. I hate the shell method. Shell method's, like, the worst thing, but it does make for prettier integrals, I guess, eventually. So, yeah, maybe I'll eventually get to a shell method, but I think by the time I finish these, shell method videos will be, as we say, like, not in style anymore.
Disqualified.
Because math has a periodic trend to, like, what's popular, and it's cool because it's every year. It's about the axis, really. Yeah, it is. Yeah, the axis is. So what I did on this video, Zach, the first video is where the axis of rotation was on the x-axis, and then this video is when it's shifted below. And then I want to do one where it's not intuitive, like how to find R inner and R outer. And then my last one is where the axis of rotation is shifted, but it's vertical. Yeah, so that's, like, my plan. But if we look at, for instance, trends, Google Trends, this is great. If you ever want to know what content to release in education and when you should do it, type in the topic. So, for instance, if I type in volume, I think it's volumes of revolution. I would just call it volume of revolution, but I think the technical term is volumes. And then look at the 5-year trend on it. You can see it's quite periodic, right? This is really cool. So, for instance, here you can see that volume of revolutions peaks, January, February is what this looks like. And then it dies off, right? This is the summer, right? June. Don't ever release, like, educational content during the summer. Just kind of falls flat. But then it peaks up again. Yeah, always around February. Like every year, like clockwork. It's January, February. If the shell method has 1 million haters, Gold is one of them. If the shell method has 1 hater, he's that one. If the shell method has no haters, that means he's dead? Is this like a logical paradigm, dude? No. Anyways, okay. So, yeah. I implore y'all to... I know some of you guys make content. Some of you guys are streamers. Some of you guys want to be streamers. You want to be content creators. Here are just some tips I found along the way for... At least if you're in the educational niche. You could also, for instance, be in... I'm trying to think of something else that's like periodic. I mean, the easy ones are seasonal, right? Like, you wouldn't put ski videos or like snowboarding videos during the summer. That wouldn't make any sense. But I don't know. Check it out. Try look at what's trending on like search, and then see if you can contribute to that body of knowledge at the appropriate time. QA is more fun than what's QA? Quality assurance? That's what QA usually means. X-Man. And what's... Oh, you're a content creator for groups. Okay. You do it for Metal TV. I don't know. Can you send me a link of some stuff? QA... Sorry, is that like video game testing? Like you're testing video games? Oh, okay, cool. Yeah. We had one of my really good friends, Zev, was a video game tester. He was a manager, actually, for doing QA for... I think it was Modern Warfare 2. Because he gave me a cool little coin that he got for Modern Warfare. Yeah. We had him on the podcast, I think 2 years ago. Oh, this stuff. Oh, okay. I see. Oh, so it's like it's a quick way to capture cool moments. Yeah. Nice. Okay. Yeah, this is great. This is another example of like content. No. Yeah, not the best Modern Warfare 2, which I know, right? Came out in like 2009. No, it's the 2021 one. Yeah. He worked on it and Halo. He worked on Halo as well. Really cool guy. Eventually will AI auto-generate? Yeah. So I have seen that too, Zach, for sure. There is this, and I've seen some content creators complain about this, where like they'll put out an original video and then some other like AI slop whatever will literally copy what they do and use like a different person with a generated voice, so it doesn't pick up on the copyright, and then they will just spam that and they will get credit for it, I guess, right? Yes, I know. I miss the OG one too. It was the best. So yeah, that's a thing for sure. You would hope that the original creator though is at least, I don't know, like the most beneficial from all this. If someone wanted to clone me or even just like rip my videos and put them out on their own accounts, I honestly wouldn't care, because that's just more exposure. Because at the end of the day, they can't like literally copy who I am. They can copy like my likeness and stuff. But yeah, I know I can see that becoming a problem. I think YouTube will start having to put restrictions. They already put restrictions on at least monetization for like garbage AI stuff. So no. And Shaq knows this as well. Shaq was getting big on YouTube because he was using kind of like baity, like clickbait, whatever, like shorts to get engagement, and then they just won't approve you for monetization. So I need an NIL contract. What's that? Oh, like a football contract for the schools. Yeah. Okay, cool. Oh, name, image, likeness. Oh, I didn't know that. Okay. That makes more sense now, Zach. That's why the football college kids get paid a lot for... Oh, that's what NIL stands for. Oh, fascinating. Wow, I think... Okay. Very cool. You taught something to me. Yeah, I appreciate it. Thank you, Zach. Okay. Cool. News... Oh, and then let me make sure I shout out all the people. Let me shout out Zach as well. Go check out Zach. Zach's a great guy. Lots of cool streams. I think were you streaming today, Zach? I've been running around all day today, but if I go check the calendar's great for this. We can go see. Oh no, Eric was canceled.
Surprise, motherfucker.
Eric, no, what happened? Okay. But looks like, yeah, MathPon's gonna be streaming tomorrow. Eric will be there tomorrow.
Good
All right.
job.
Rescheduled for tomorrow. Abstract Algebra, very cool. Oh, and we're gonna play games. Yes. Oh, so we gotta go vote on. We gotta decide the game. You guys were voting on it this week. Let's see what we got. I think it's under the poll of the week. Where did we put it? Yeah, here we go. Okay, cool. All right, there we go. All right. Honestly, sad story. What's the TLDR? Or should I wait until your stream tomorrow to get the TLDR on like what happened? Okay, let's see. Votes for Friday's February 6th game. Wow, a lot of people want to play chess. Wow. Okay, cool. All right. Well, we'll see. Let's do the picker wheel. You were gonna raid Stooky today? Stooky. That's okay. Things happen for sure. Kids get sick. Mental health needs to be taken care of for sure. I'm finding that more and more as I get older. I'm like, wait a minute. I need to make sure that I, the source, can still continue to burn and create light. All right, let's see. So Fortnite had 1 vote. Rocket League had 1 vote. The finals had 3 votes. Wow, I don't think we've ever played the finals had 2 votes. All right, so the finals. And yeah, so this is what we're gonna do tomorrow's game during recess. I said this year again I would get back to the roots of playing more games with students. So I'm committing to this. My Friday evenings are spent playing video games with you, the people. So, but I have you guys vote on what we should play. So chess got 6 votes this week. Eric says, my roommate had a job interview scheduled today and our internet was kind of spotty, so when I started the stream, it immediately crashed. We got to get you guys some better internet. The stranglehold that these service providers have is absolutely criminal. The interviewer kept him there for 4 hours? No, dude. I've been interviewing people for this new project we're getting funded, and I capped them at 30 minutes. I don't know what the hell I would talk 4 hours with someone. Oh, that's crazy. Madness. I'm so sorry for your friend. Well, I hope they get the job. Maybe it's a good sign. Yeah, that's a good sign. You know, all right, there we go. All right. 1 vote for Fortnite, 1 vote for Rocket League. Got that. 2 votes for the finals, 6 votes for chess. Let's see what game we're going to play. X-Man says that's me. I love Rocket League. Chess is it's a big one, though. Oh, is it going to be the finals? No, it's going to be chess. All right, I'll announce it. Chess tournament tomorrow. Come on by. It's super fun. I think we had 10 people join, or 8 or 9 people. It was really fun yesterday, or last week, sorry. So I'll make the announcements today. Dr. Gold, would I employ you? So actually, I have some ideas, and I will announce these probably next month, but I do want to maybe provide jobs for you guys, students, members of my server and stuff. Maybe particularly with like fundraising, because I'm finding I spend a lot of my time trying to do all the other stuff like behind the scenes, and I don't have enough time to go out and like solicit funding for things. But what if, for instance, y'all had opportunities to be able to go solicit funding, and then like any sort of canvassing action, we just kick back like, I don't know, 50% of whatever you guys raise back to yourselves. All the money goes to the students anyways. Like, I don't get paid for any of this, but we do need funding to, for instance, run tournaments, pay for big prizes, keep the server and the electricity on. So I do have some ideas about that, opportunities, which I'll open up, I think, in the next couple weeks. And then also, one of the jobs I work has some cool, like, content curriculum development stuff that you don't need to be super knowledgeable about, but you just have to have, like, kind of a basic knowledge of science and math. And it's more for myself, it's very laborious. Like, it's very monotonous, and I don't want to code AI to do it. So I'm going to talk about maybe getting some contracting opportunities for that. So if you guys are, again, passionate about any sort of like physics, science, math, whatever material, we may have some positions for you guys to work with that as well. So, okay. Awesome. You got me with the emotional support. Bless. Okay, let's see. Let's go help you guys out with some homework questions and start off the stream. All right, welcome to Natural Education Office Hours. My name's Dr. Gold. So this stream helps you out math homework, science homework, all sorts of fun stuff. I guess we were doing chemistry yesterday. Actually, the queue's actually quite open so far. So if anyone has a question, please submit. Zach, if you want, because there's no one in the queue, if you want me to teach you RLC circuits, I could also do that. All right, 1K's gonna spend one. Okay, cool. Eric's already got one. Eric's like, hey, what's up? He's like, I got you. What are you gonna do to me, Eric, though? Eric, please be nice, be gentle. All right, let's go see. All right, then let me make sure all the chat stuff's working. Connect to that. Connect. Why is YouTube not wanting to connect today? There we go. Cool. Activated. All right, let's see what's on the queue. Eric. Sylvester's Sequence. Okay. Sequences in series. Also one of Zach's favorites, right? Here's hoping today doesn't finally have... I'm going to call upon my Romanian vampire friend. Where's Narosky? Need Narosky's help on these. Okay. Okay. Sylvester's sequence is defined as A1 equals 2 and AN plus 1, oh wow, is equal to 1 plus the multiplicative sum from I equals 1 to N of A sub I. For any sequence, compute 1 over A1 plus 1 over A2 plus 1 over... Okay. What's up, Skell shit? Now wait, now here's my question, sorry. Why is there 2 here? Why are these the same thing? Dealing with series is torture. Yeah, it is torture sometimes, dude. But we welcome the torture, I guess. Are these the same? Is this the typo? Oh, A sub n minus 1 and then A sub n minus 1. Got you. Thank you, Zach. Yeah. I see. This is part of the subscript. This is not part of the subscript. Today I learned. Okay, cool. One sec. No. Okay. All right. Maybe let's write out some terms, right? So A1 is equal to 2. Cool. So we have 1 over... Okay. Yeah, all good. Yeah, Zach, let me know whenever. Can hop in. And we also don't have to do all of RLC circuits. I can give you like a primer now, and then we can like go into like another set and then another set. We can do it over like a couple days too. Any more analysis? Not yet. 1K's got a question in there, but we'll check. All right, so 1 over A1 would be 1 over 2. And then 1 plus A2. So A2, which is the n plus 1 term, right, in this case. In this case, A2 is the same thing as n equals 1 for this. So that would be equal to 1 plus the sum. This is called a multiplicative sum. This is like an adding sum. This is a multiplying sum. And then this is going to be I equals 1. So A1. Oh, so A1 was equal. So this is like A1 times and up to n. Up to n. Okay, so it's just that. Or they call it a product. A product sum. I guess that makes more sense. Yeah, okay. Okay, so then this is over 1 plus A1. Fake word. Sorry, multiplicative sum is not a word.
Huh?
It's like adding but with multiplying. Okay, you guys are right. Yeah. Multiplicative series. Series maybe. Okay. So this was n is equal to, well, sorry, no, this one is n equals 1, right? Yeah. This is n equals 1. Just call it a product. Yeah, okay, all right, I'll just call it a product, guys. You guys are okay, I'll just call it a product. Okay, and then let's go for A3, I guess, right? So A3 would mean n equals 2. So that would be 1 plus A1 times A2, right? I see. Where this whole thing, I think, is A2, right? Wait, let me write this out. I see. And then I think it's 1 over 1 plus A1, A2, A3. And then they want to go all the way up to n minus 1. But then the nth one, they want to stop at minus 1. Okay, so then you go all the way up to 1 over... And then if this is minus 1, that's going to subtract that one. So then this would be A1, A2, A3, ... AN. I think. Does this look correct so far for, like, the series? I think it does. This is like n equals n. Looks good. Okay. And then the cool thing is... So correct me if I'm wrong. So A2 is then this whole bottom part right here. Pi is used to represent product as sigma is used for terms. Oh, well, that makes sense. P for product, S for sigma for sums. Yeah, that would make sense. I see. We can't call it a product sum, though?
Oh shit, not good.
I'm messing with you guys. Okay, so I think this would be 1/2, and then this would be 1 over 3, right? Because this would be 1 plus 2. But then this would be plus 1 over 1 plus 2 times 3. Yeah, that's some product you got.
Oh shit, not good.
This is becoming a mess. Because then this is gonna be 1 over 1/7, right? So then this is 1 over 1 plus 2 times 3 times 7. Sigma. It's one of the sounds. We have a bunch of sounds. Yeah. Okay, and then this would be 1 over... Oh, man, it's just big. What's that? 6, 42. 1 over 43? Okay. And you want to know what... For any n, compute it. Okay, so we have 1/2, 1/3, 1/7, 1/43. Let me see if I see a pattern here. So this is equal to this times 1 plus 1. This is equal to this times 2 plus 1. This is equal to this times 6 plus 1. Let me see if I can kind of write a pattern here. This is times 1 plus 1. And then this is equal to... Or sorry, this is 2 times 3 plus 1. Sorry. No, this is what I want to say. Oh, wait. No. This, I think, I want to write. All right, this is 1 times 2 plus 1. And this is 2 times 3 plus... I want to see if it's something related to just the term beforehand, but I don't think so. Because it would be nice if this was 3 times this plus 1. but it's not. This is equal to 6 times 7 plus 1. Okay. I was hoping it would simplify out or something. Because I see, like, 2 plus 1, 6 plus 1, 6 plus 1. It's like 42 plus 1. It's a factor of 3. It's a factor of 7. No. Oh, but this is a factor of 2 times 3 times 7 plus 1. Right. Yeah. And I understand, right? Yeah, because that comes from. I mean, it's literally just what we wrote, right? it's always the other two. I was trying to see if mathematically that or algebraically that simplified to something nicer. Yeah, which is it's how it's defined. Yeah. Fascinating. Well, let's see. In order to add fractions, I need them to have the same denominator, right? So maybe we can see what would cancel. I think the 1 plus kind of like messes with things.
You done messed up, Aaron!
This like really messes with things, right? Because if I multiply everything here by like 43, nothing's gonna cancel. Right? And also, like, I can't really get this. Yeah. Oh, man. Nice, X-Man. Go do your workout. You doing leg day today? I'm gonna do leg day. Ab day. That's not a day. Ab day is not a real day. Let's see. For any n. You don't just do 7-minute abs? My one friend would argue that you do ab day every day if you're engaging your core at the gym correctly, but I agree. I would also do an ab day. Okay, so this would be 1 plus 2 times 3 times 7 times 43? Josh on TikTok. I can do linear algebra. Did somebody ask? Hypothesis, all denominators are prime. That's actually kind of cool if that's true. Well, let's look. What would this one be? What's up, Taco? Where's my calculator? Well, I guess 2, 3, 7, 43 are all prime. And wait, if you multiply prime numbers by each other, is that a special property? Balthar has an idea. Thank you, Balthar. Balthar says, try to see what happens if you write a to the n squared equals a to the n plus product from 1 to the n a sub I. Proof, all denominators are multiple are one more than a multiple of 6. Well, except for this one. What math is this? This is just like a fun puzzle is what this is. I just wanted to see, for instance, if this bottom is prime as well. Times 7 times 43 plus 1. Gee, that's just ugly, dude. What? 1807? Two and 3 are special cases. Okay. Is 1807 prime? Yes, it is prime. Wait, no. Not is it time? Is it prime? No. Is it prime? No, 1807 is not prime. Uh-oh.
Bruh.
Because 13 times 139. It is semi-prime, apparently. Just 6:07 is 6/7's prime time. Josh says, thank for your help last semester. You helped me with my understanding, and I aced my Physics 1 final. Hell yeah, good job, Josh. Appreciate it, Josh. Wait, someone else. Sorry, where was this? Balathar said, try to see what happens if you write a sub n squared. Wait, Zach sees something. Zach, do you see something? Oh, let me get rid of the Q, sorry. What was that? Yeah, 1807. That's what I got, I think. It was correct. Right, 42 times 43. Oh, it can't be prime, right? Because you have 6 times 7. Maybe. Wait. 6, 7? Yeah, it was 1807. Prediction: in 3 minutes, you will move on. Yes, I probably will. You're probably right about that prediction. Go down to n and then multiply by a sub n? Oh, I see what he's saying. Because he's saying they're going to cancel. Uh-huh. I think he's saying for this, right? Okay, let's take the case where we just go up to a sub 4. Okay, let's go to n equals 4, right? This would be n equals 4. Wait, there's one more. Wait, this is a1, which is okay. This is n equals 1, n equals 2, n equals 3. Or that's little n, sorry. But then we go to the one beforehand. Uh-huh. So wait, I think... Yeah, okay. This is what would happen. Yeah. What's up, Isabella? What's up, nerds? Okay. So you're saying if I have up to here, right? Then what happens if I multiply through just by... and then this, I guess, is like... You want me to multiply through by this? This whole thing? I think the 1 plus kind of fucks with things, though. Like, nothing's gonna cancel. Right? Oh, why did YouTube die? Come on, YouTube. Stop being sad. Baltahar says a sub n plus 1 equals 1 plus the product from 1 to n. Yeah. So a sub n equals 1 plus the product from 1... Oh, okay. Oh, I see what he's saying. I see. You're saying this is a n sub 1. What's a sub n? Got you. Okay. Wait, a sub n plus 1 equals 1 plus a1, a2, a3, right? Dot. A sub n eventually, yeah? So a sub n is equal to a sub n plus 1 minus 1 all over a1, a2, a3, dot, 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 a sub n minus 1. Is that what you're saying? Oh, wait. You're saying if this is this, and then if I re-index, so for instance, a sub n minus 1 plus 1, right? Is equal to 1 plus... This would be then... A1, A2, A3... an minus 1, right? I think. So then a sub n is equal to 1 plus a1, a2, a3, dot, dot, dot. This is a sub n minus 1? Then what's the expression for a sub n minus 1? Okay, I think Jeff's correct. I'm gonna punt on this question. You do give me fun ones, Eric, though, all the time. But I just don't know how to do this. But I'll put it in my Discord. So, Baltahar, if you want to maybe help out with how to solve this one, because I'm not getting it, and we have some other students I gotta help out. You can always go do that in our Discord. So here. Before you move on, will you compute the n equals 4 case? The next one? One sec. Yeah. Let me put this in the queue so I know it's there at least first. Yes, I will write the Discord. So, Baltar, where the Discord is, so the same website people are using to submit questions here, the actualofficehours.com, there's a link here to say join our Discord. And then once you join that there, you'll see it pop up in this channel. Where is it? It's going to be in here. In the homework help channel. So this is where it'll be posted. What's up, Naroski? If you want to go tackle this one, Naroski, for me, and maybe explain it to me afterwards. I put it in Discord. It's in the Discord, but this is one that Eric came up with. It's kind of a tricky one. I started doing n equals 4. Was this n equals 4? I think it was. Is this not n equals 4? And then what? This is 1 over 1806. Because then it's the last one minus 1. I think we get it confused. There's so many n's. There's like little n, then there's like big N. I need like 2 different variables on thing. 1 over 42 is the n equals 4. Oh. Oh, I see. This is little n equals 1. Yeah, okay, got you. This is little n is what I meant to say. Right? Little n equals 3? No. Ugh. 1 over 42 is the last one. I see. Okay. Because you go up to this one. This is like the n minus 1, and then it's this minus 1. I got on Twitch. Yeah. TikTok is laggy. Yes, thank you, Velo. Is that you, Baltahar? Nice. Good to see you. Okay. Let me help out 1K. And then Narowski's gonna like chew on this one, and maybe Baltahar too if you want to. It's in our Discord, please. Yeah, it's messing up my brain right now. I need my brain to be okay. Let me see what 1K's got for us. There we go. I like this. Happy math. I like the other math too because it challenges me. I like being challenged. But at some point, my brain's not working any further. I've reached the limits of my computational powers. Okay, let's see. Determine whether each function is even, odd, or neither. Does it have a line of symmetry about the y-axis, point symmetry around the origin, or neither? On what channel? So in the same... what's your name in Discord, by the way, first off, Velo? Or I think if you just joined, I should be able to see you pretty quickly. Because I'll tag you in it. V Sigma? Cool. There you go. I tagged you. It's right here. There's the question, and then, yeah, if you want to post anything in there. Here, let me make sure you have perms to do that. I can't post links. There you go. Cool. All right. Let's see. Even, odd, or neither. Okay, so for an even function, you need just even powers. At least for polynomials, you have to have just even powers of x. Narowski says it's equal to 1. And he says it's ridiculously easy.
Surprise, motherfucker.
Now I feel retarded, Narowski. What? It's okay. Okay. Even exponents only. That implies an even function. We can also, you can test that also. You can say f of negative x is equal to f of x. And that'll always happen for for things with even exponents, right? So say, for instance, like f of x was equal to like x to the 6th plus x squared. Notice if I put like f of negative x in, if I put a negative into here, let's use a different color. That each of these even powers basically gets rid of the negative. Right, so to the 6th power negative, this is literally the same thing as just x to the 6th. And to the 2nd power negative, yeah, you see that, 1K? Yeah. So this is why, for instance, f of x equals f of negative x, and that's an even function. Yep. Okay, so this one right away, because you have just 4 and 2, this is even. The same thing happens with odd functions, or like similar, it's just different. So odd functions... or we can say odd exponents only. You can check the least degree. No, you have to check all the degrees, technically. Oh, I see. I think you're doing what... So, for Baltar, I think Narowski's literally doing what Baltar was saying, which was like, solve. Yeah, solve for a sub n, maybe? Yeah, no, but 1K, with odd functions, they all need to be odd exponents. So here, for instance, this is odd because it's to the 3rd. And then if it was to the 1st power as well, that's also odd. So that's an example of an odd function. Let me see if I can show you like why that is. Yeah, okay. So for odd functions, the way they write this is that like f of x is equal to negative f of negative x. And so, for instance, if you, let's say like f of x was equal to x to the 5th plus x to the 3rd, right? And then let's replace it with f of negative x. Right? Here, let's replace these exponents. Okay, so then if this is to the 5th and this is to the 3rd, here's the cool thing. With odd exponents and a negative inside, that negative is going to come out, right? The negative persists. So now you would have negative x to the 5th plus negative. Oh, it's a telescoping sum is what Narosky says. So for it to be even, the signs must not change, and for it to be odd, all the signs must change. Correct. But so if all the signs change, notice how this is the same thing as you could factor out the sign change. You could factor out the negative, and then this would be x to the 5th plus x to the 3rd, right? And this is literally negative f of x, right? Because remember, this thing was our original f of x. Yeah. So that's why when you have all odd powers, you get an odd function. So yeah, this is odd. And then if you have a mix, so in this case, we have like 5 and we have 2. This is a case of neither. No. Yeah. What about sine x cubed? Ooh. So this is for polynomials. Sine x cubed. Well, so sine is inherently even. And so that's an even times an odd. No, sorry, sine is odd. So you have an odd times an odd times an odd times an odd. All right, or here, this is a little Jeffrey side quest. He asked about sine cubed of x, right? Which is the same thing as sine of x times sine of x times sine of x. Yeah, sorry, Jeff. Let me put some more respect on your name and put an extra f. You have earned that. Okay, so if this, for instance, were f of x, what would f of negative x be? Well, so here's the cool thing about sine of x. So sine is considered odd. So sine of negative x is equal to negative sine of x. Because sine looks like this, right? It's like a flippy flip. I see that, Narosky. Yeah, I see that down here. Yeah, I'll check that one out. I'm curious. I think my hardest thing I have, Narosky, with those types of questions is I get too flustered if I'm not understanding like the notation. It's hard for me to visualize it, I think, sometimes. Okay, so in this case, you would have sine of negative x, sine of negative x, sine of negative x, but each sine of negative x is the same thing as negative sine of x. So you then have negative sine of x times negative sine of x. Or sorry, sine of just sine of x. Yeah, not sorry, the negative goes away, right? So it used to be negative x, and now it becomes negative sine of positive x. There we go. All right, and then a negative times a negative times a negative. So negative times negative is a positive times a negative is negative. So then you get negative, and then all the signs are still together. So you get negative, come here. There you go. So you get negative sine cubed of x, which is equal to negative f of x. So this is odd. That's like the in-depth way to show it. You can also say that this is, so since sine, whenever when you're adding functions, they have to all be even or all be odd in order for the overall thing to be odd or even. When you're multiplying, and you'll use this trick a lot in like calculus and like simplifying integrals, it works the same way as like negative and positive. So odd times an odd times an odd is the same thing as negative times negative times negative, which ends up being negative, which is also odd. You can then think of even functions as positive. So like an even times an even is still even. An even times an odd Is that odd then? Wait, even function times an odd function? Wait, So example of an even function like x squared, odd is like x to the third. Yes, is also an odd. Yep, because that would be x to the fifth. And then an odd times an odd is even. Yeah. Oh, and then I guess Zach says sine x cosine x is odd. Okay. Yes, and that makes sense then, right? Because that's an even times an odd. Because sine is even, cosine is... No, sorry. Sine is... Sine is odd, cosine is even. So odd times an even is an odd. Yeah. Even times an even is also even. Okay. Yeah, that's how those all work. And they work the same way as like positive, negative, right? Look, positive, negative is negative. Okay. Yeah. So when I say odd even here, I'm talking about like not odd numbers. I'm talking about odd functions. Sorry. And yes, it has to do with multiplying functions, especially if like they have exponents, becomes addition of the exponents. So for instance, an odd function could be like x to the third, right? An even function would be like x squared. And so if you multiply those two together, you get x to the third times x squared, and that's equal to x to the fifth, which is also odd. And so how I like to think about it is it's a negative times a positive, which is giving you a negative, which is odd. Yeah, and also x plus 1 is not odd, correct? Because this is when you're multiplying functions together. If you're adding functions together, like x plus 1, this is an odd function. This is x to the 0, which x to the 0 is considered even, right? So an odd plus an even is neither. An odd times an even, however, is odd. So yeah, when I write here, we're talking about like functions. Yeah. Okay. Dun-dun-dun. Okay, so then about symmetry. Interesting. So, symmetry only exists about the y-axis if the function is even. Yes, thank you. Yep. Yeah, so symmetry around the y-axis is only if it's even. And the reason for that, right, is because I need, like, whatever over here to equal the same thing over here. Well, well, actually, I can just copy paste it. There you go. Something like that. Well, yeah. There you go. I can't draw mountain ranges today, or humps or whatever. So, yeah. And then this is the y-axis right here. Rotational symmetry is odd, correct? Yeah, so this is okay, so this is also called reflective symmetry, correct, Zach? Whereas let's say something, for instance, like x to the third. X to the third would look something like this. Or let's put it in green, actually, sorry. Yeah. And so this is rotational symmetry about the origin, right? Because what you could do is you could take this yeah, it's, well, right, because it doesn't flip over this way, right? It also doesn't flip over this way. It wouldn't be a function if it flipped over that way. No. And it's also like not symmetric about this. So it's like if you took this and like you rotated it that way. That would get you the same thing. Yeah. So only even. So this one has line symmetry. This one definitely does not. This is neither. I mean, you know, I don't think you can have anything. And then point symmetry around the origin. Is that what they mean by? Is this called point symmetry, you think, Zach? When it's odd? It's kind of a weird word for it. Yum. The parody. Okay. Yeah, and I think that's it. Cool. Does that make a little bit more sense to you, 1K? All the different stuff about this? This was kind of a fun little side quest, too. Yes? Okay, awesome, great. I'm glad that makes sense. Nice. All right, we're going to take that solution, put it in. I see V Sigma. You also submitted a solution as well. That's very cool. For the one Narosky for Eric's question. Eric's challenge, I would say. It's not Eric creates these questions, these challenges. And this is 1K. A cross B cross A divided by its sides yields an orthonormal basis for the plane containing A and B. What? Where does that come from? What? Let's see. So yeah, Narosky does this with latex. So the way you do it, V Sigma, by the way, is all you have to do is put the double dollar signs in between like tech, and then it'll automatically render it within the Discord, which is cool. But there's another solution that you wrote. Okay. Uh-huh. Okay, I'm gonna check this out. I feel like this... Yeah, and this is what you're talking about, Narosky, the telescoping series that happens. Okay. Let me see what Deeps has, and then I might go through that. Ooh. Oh, Jeff. Oh, you were answering the next question.
Yeah.
Thank you, Jeff. I see what you're saying. Jeff was helping out with this one. That was just random what you were saying. This is some linear algebra. All right, consider U is a vector, V is a vector. Write U as U1 plus U2, where U1 is parallel to V, and U2 is orthogonal to V. Okay. So you're writing that. So you're writing V. Wait. So U1 is parallel to V. Okay. So this. Let me just try to visualize this. I like drawing graphs for linear algebra stuff, because I think it's like cool. Okay, so vector -2, 1, 4. All right, so if this is x, this is y, and this is z. This is 2 back on x, 1 up on y, and then 1 up on z. So this right here is kind of what I would call like vector v, right? And I want to write another vector, u, where u is 3 this way, 1 this way, and 0. Use GeoGebra. Yeah, but you don't get GeoGebra on the test. You're all right, though. Okay. Okay, and then this is vector u. And I want to describe u in terms of vectors that are either, like, perpendicular to v, sorry, parallel to v, and perpendicular to v. I see. Uh-huh. Okay, okay. So this is like U1. And then this is like U2, right? And I need a sum of these two things. The pain comes in because you're in 3D. Remember, two vectors share a plane. Exactly, right. So if U2 was pointing like kind of across the y-axis and U1 was across V, it would look like this, right? And that wouldn't even encompass this.
Surprise, motherfucker.
Right? So I need to find something that encompasses this. Oh, this is actually really cool, actually. Okay, wait a minute. Let's say that U1 points in the direction of V. Let's just say it is V. It's V1. It's just V, right? Then I just need another vector U2 such that when I cross these two vectors, I get the green vector U that I'm looking for it to be, right? Because the cross product of two vectors produces a third vector, which is orthogonal to both. And I think this is kind of similar to what you're saying. You're saying A cross B cross A divided by its size. The cross A part is cool. Because, okay, once I figure... Okay, here's how I see it. I see it as, like... I want, like, U1 cross U2. A cross B is not in the plane. It's perpendicular to both A and B. Correct. Oh, I see. But it has to contain it. Yeah, okay. U1 cross U2 would get me... If that was equal to U, then that would not contain U. But if you cross it again, yeah, okay, then you have a vector in the plane perpendicular to A. Here my A is V. Yeah. You want vectors parallel and perpendicular to V. Yeah. Okay. Josh says, I think the first step is to use the projection V on U formula. Let me think why that is. Because that would give me the vector for the amount of V that is in the same direction as U. Okay. Which will get you U1. Ah, okay. Because, yes, that would be the amount parallel to V that points in the direction of U. I like that, Cody, yeah.
Oh, yeah.
Cody was like, hey, Cody says make a vector and test if it's orthogonal to vector V. Let's see. I like the projection idea. Let's do that. And I think, man, how do they write this? When they say projection of V on U, I think they write it like this. Yeah, it has to be orthogonal to V, but in the same plane as U and V. Okay. I can remember my projection formula. I think it's like dot product and then like you multiply by the vector and divide by the magnitude or something. There we go. I want something that looks nice though. This actually kind of looks kind of cool. Here, I like this image. Guys, give me all the tough ones today. Okay. Yes. I like this cute little easy. So friendly. Oh, so then I wrote it wrong. Sorry. Yo, what's up, Pen?
Good job.
We're doing linear algebra, your favorite. Shout out, Pen. Pen's great. Ooh, I like that better. That's actually a better way to look at it. Okay. Yeah, let's take that from Narosky. Except I hate U and V because they look like the same thing. It's so hard to tell the difference between U and V. Sometimes you're just like, wait, what? Which one is U? Which one's V? Super hot, right? Yeah. But we want to project V on U. So I think we don't want to project U on V, right? I think I flipped them in this case with U and V. Is UV equal to VU? No, because then this matrix is different. Sorry, this vector becomes U. Oh, is U dot V equal to V dot U? It is. Wait, yeah, right. Aren't dot products? Oh, okay. Wait. I think Narosky, I think your bottom formula is missing something. I think it should be over U dot U. Yes, dot product is definitely commutative. Yeah, I think Narosky, you were close. I think it's this. And then I think this is dot A. Yeah, V dot V, right? Yeah. Why does someone just not have a nice little... Why is it so hard on Google Images to come up with something? Sucks a year of life from the vampire.
Oh shit, not good.
Oh no. Okay, here, let's use this one. Okay, the projection of V onto a line spanned by S is this vector. Okay. I want to project U onto V, right? Because everything has to be parallel to V. I think this is what I want. Okay, so that's going to equal U dot V. I want to project you onto me, once again making this top 10 my week. Okay. Okay, and then this is over V dot V, right? And then this is multiplied by vector V. Yes. Yeah, it's the denominator, Narowski. You have v dot u on the bottom. Ooh, woo. Okay. Oopsies. Yeah, that's why they say you lose a year. Okay. Because that will give me the component of u that's parallel to v. So that's the parallel component. And then we got to go find the... Yeah, it's much better, Narowski. Love that. All right, what's u dot v? So that's 3, 1, 0. Dotted with -2, 1, 4. All over v dot v. So -2 squared plus 1 squared plus 4 squared. What's up, Sharon? And then this is in the direction of vector v. Yeah, magnitude v squared. Okay, so let's multiply it. So 3 times -2 is -6 plus 1 plus 0 all over 4 plus 1, 5 squared plus 21. Am I right? 16 plus 1 plus 4? Yeah. Okay, so that's actually really ugly. I lost my plus 1. Wait. Oh, I did, sorry. Yep. So plus 1 plus 0. Oh, even worse though. Alright, -6 plus 1 plus 0. Okay, so we get -5 over 21, really? Is it negative? Projection of u. Yeah, I guess so. Because, yes, okay. Okay, so it's -5 over 21. -214. So this is equal to u1. I agree with that. That's parallel. As ugly as it is, right? All right, how do we find the perpendicular amount? If I do u dot v, subtract. Oh, okay. Eric, why do we subtract? Oh, yeah, no. SYM is symmetry. No, shut your mouth. Yeah. Ah, yes. Okay. Oh, I've seen this one before. Yes. Okay, great. Yeah. Yes, okay, because u1 plus u2, where, right, this is like u parallel. This is like u perp, has to be equal to u. Right, so u2, that's, oh, I've seen this before, is equal to vector u minus vector. 2 good calculus questions? Oh, I'm happy. Okay, all right. So then vector u was 3, 1, 0. Okay, so you have 3, 1, 0. Minus, so then minus is plus. So plus 5 over 21, -2, 1, 4. It's not very nice. Okay. So what is that? -10 over 21 plus 3? It just looks so gross. I just don't like this. I guess I can multiply everything by 21 over 5. No, that's even worse. Should we like make this look nicer maybe? Like, I think I can just multiply everything here by 21, right? So this would be negative 42, 21, 84. And then when I multiply that through, I'm going to get negative 5. Negative 2. You don't want to change the lengths? Wait, can I not change the lengths? Oh, because, sorry, U1 plus U2 has to equal it. Yeah, sorry, we can't do that.
Surprise, motherfucker.
Sorry, yeah, no, you're right. I can't. Okay, we just have to leave it as it is. You're right. I forgot that we want it to add up to U. Got you. I thought we were in, again, I remembered like basis land, and I was like, oh, we can just like write it as whatever. We don't care about the length, we just care about the direction. Fine, okay. So this is 3 minus 10 over 21, comma, 1 plus 5 over 21, comma, 0 plus 4 over 21, which, I don't know what that is, 63 minus 10, so 53. 16. Or no. 26. 4. 1 over 21. Yeah. Okay. And this is vector U2. Fair enough, yeah. I guess we could write this as something nice, right? I could say that U1 is equal to 1 over 21, and then this would be 10, negative 5, negative 20. Yeah, so we found U1 and U2. I think we're done. No? That's all we wanted? Oh, song joke. Kids these days probably don't even know who U2 is. Everyone who had an iPod knew who U2 was because they forced it to be on your device. Like, you had to listen to U2.
My man.
Okay, cool. All right, I think that's correct. We can throw this one in the chat real quick. Just have it while it's working. Tell it to solve this. Go, Clanker. Just go solve it. I'm pretty sure I can find it and figure it out. Yeah, I've seen this one before, actually. I always forget. The subtraction trick, Eric. Yeah, it's great. I forgot about that one. Let's see what chat got. Chat gets a bunch of nasty stuff as well. Yeah, look at all these 21s. Just ugly. Okay, there you go. Let's see if that's what we got. I'm pretty sure that's what we got. All right, U1. Right? Yeah, 10, negative 5, negative 20, all over 21. 53, 26. Oh, they got 20. I got 4.
Surprise, motherfucker.
Uh-oh. Where we mess up? Oh, yep. 5 times 4 is 20.
You're not that guy, Phil. Trust me. You're not that guy.
Oh, no. Come on, Gio. Yeah, there you go. My bad. But that's why AI is useful. All right, good job, Deeps.
Well done. Well done.
Let's go put that on our Discord. And then Anthony's got some questions. Cool. Are you in our Discord already, Deeps? I don't see your username. You should get a K-Tel gold t-shirt. What's that? All right, let's see. No, you can upload as many questions as you want, Anthony. Queue is open. You don't remember K-Tel? They made compilation albums, vinyl. I don't. Is that before my time? KT Corp. No, sorry, K-Tel. This is apparently K-Tel. It's apparently a Canadian thing. Or here we go. Oh, you know what this is? This is Kids Bop's. This is hilarious. Yeah, this is, or what it used to be called is now that's what I call music. This is I think the CD version, Jeff, of what you're trying to describe. Now that's what I call music. 87. Yeah, how many are they up to? The biggest new hits on one album. Yeah, so back in the day, you couldn't buy individual songs. You had to buy CDs. So it was very useful to have all the top songs from all the top artists on one CD. I think it's hilarious. I wonder if they still do this, because nowadays you can just like stream songs. Like, who buys CDs anymore? Yeah, let's see. When did they stop doing this? Oh, apparently it's still going. Apparently it's up to number 122. That's super fun. Wow. Yeah, and of course these albums go like platinum, right? Because it's just all bangers. It's all like the top songs ever. It's cheating is what it is. It's very difficult for an album to go platinum. You need like a lot of streams on that album. But if the album is just straight bangers, of course it's going to do well. All right, Anthony, let's try to help you. Trace or copy the graph of the given function f. Assume the axes have equal scales. Then use the method of example 1 to sketch the f prime below it. Okay. So this is making f prime graphs from f graphs. Cool. And so when they mean like below it, Anthony, I think this is kind of what they want. We're gonna like do this, but then this is gonna be, so this is f of x. And this is gonna be f prime of x. So what I always like to look for, whenever, so this is gonna be the graph of the derivative. I look for where the derivative is 0 here. And those are what I call like critical points, or very interesting points for you to look at. So for instance, here, the derivative is 0, right? Derivative measures like what the instantaneous slope of the function is. So that's 0 here. It's 0 here, and it's 0 here. So on my graph down here, and this is kind of probably what your teacher wants you to do, you want to line this up. And you want to be like, okay, cool, that happens there. Now let me take this. Let me line it up here. Then this one, we're going to line up like right here. Okay? I know the derivative is 0 there. Now what I want to do is I want to see what's the behavior, like what's changing. Wait, what? Wait, what language is this in? What? Apparently, my auto mod wanted to hold it. I think that's Cyrillic. I don't read Cyrillic, unfortunately. Okay. So, when we go from here to here, let's look at like what's happening to the derivative, right? So the derivative starts as being flat. It's 0. And then it's going to creep up to being positive before it then starts creeping back down to being 0. You're not trying to do all that? Oh, well. Yeah, unfortunately guessing and checking doesn't work all the time, right? Anyways, okay. This is how they want you to do it. They want you to find like this point, right? Okay. And then the derivative is 0, it becomes really positive. And then it goes back down to being 0, right? And then here, the derivative starts becoming very negative before eventually becoming back down to 0. Before going eventually back up to 0. Okay, there you go. And then from here, right, slope goes from being 0 to very, very positive. So you can just draw this. And then from here, right, slope goes from being very negative to kind of negative to 0. So then you just draw this. And there you go. It's like kind of a weird looking Wario. So that's how you do that one. Oh, sorry, negative. Sorry, I fucked up. Sorry, that's what I meant to say. Thank you. I got it wrong. Yeah.
Surprise, motherfucker.
Yeah, there we go. Sorry. This is what I meant to say. Sorry. Yeah, the left and right stuff can start to mess with you. Yeah, sorry. Always think when you're going from left to right. So this is negative. I know it looks like this thing's like going to the left, but like as you go left to right, the slope goes from being more negative to less negative. That's right. More negative to less negative. And eventually it goes to 0. Yeah. Okay, there we go. That's correct. Does that make sense, Anthony? Let's see. What's another fun one? I think which one? Maybe let's do 6, because you probably have the odd answers in the book, right? Is it supposed to be pointy? So not quite, right? Because you're right. It's probably not supposed to be pointy because the derivative, this is smooth, right? There's no pointy points here. Okay, so yeah, you're right. Probably should be something like this. You're right. The derivative's not changing instantaneously. There you go. That's probably correct. C minus infinity function. Okay, same thing for kind of this one. So look where the derivative is 0. Derivative is 0 here, right? So I'm going to put something there. And then look what happens before and after. So before and after, the slope is like kind of positive. And then it quickly ramps up to being very positive, which is the maximum positivity is probably here, right? This is probably the point where it's the most positive, and then it comes back down to being 0. That's called an inflection point. Yes, pointy is non-differentiable, right? Yeah. So it probably looks, I want to say something like this. And then here the slope goes from being 0 to like very negative to then being less negative. So then it would look like this. Maybe something like that, yeah. Yeah, and everything here is smooth. And then, ooh, this one's cool. Let's do this one real quick. Okay, so here, slope is 0. Here, the slope is like positive infinity, right? So let's just put like a really, really tall number up here. It's actually like asymptotic, right? So you could actually draw, I think, like an asymptote for it. Or no, the function does stop. But I think the derivative is still like asymptotic. No? Yeah, the ends would be undefined. Yeah, I think and so it goes from being like very positive to being 0. So I think this ends up looking like this. Right? And then here would look like this. Yeah, this one you could find it analytically if you wanted to. So maybe you haven't done this yet, right? The equation of this is it's half a circle. So x squared plus y squared is equal to r squared, describes a circle. So then you get that y squared is equal to r squared minus x squared. So y is equal to plus or minus the square root of r squared minus x squared. But this is, yes, exactly, Val. This is only for the top half of the circle. So you just take the positive part of the square root. So yeah, so y is equal to, and then I'm going to write this as r squared minus x squared to the 1/2. So if you want to figure out the slope, which would be dy dx, you may have not done this yet, Anthony. This is going to be a derivative using the chain rule. So this becomes 1/2. And then it's r squared minus x squared all to the negative 1/2. And then it's times negative 2x. So that ends up looking like negative x over what? This is the square root of r squared minus x squared. Where in this case, this distance here, right, this is equal to r. This is really technically minus r, I guess. So this is the slope. And so you see if x is negative, right, a negative here will make this positive, and then this will blow up whenever x gets close to r, because then you'll be dividing by 0. And by the same token, if you go onto the other side where x is positive, now the top part of this numerator is negative, and then a negative divided by 0 is going to then become negative infinity. So that's where this comes from, actually. Yeah, if you wanted to, you could graph this. Here, we can graph on Desmos, actually. So we're going to graph negative x divided by the square root of, and let's just say the radius was equal to 4. 4 squared. Maths. 4 squared minus x squared. And there you go. You see how this is also the same, like, kind of, I think it's kind of what we have. Yeah, it's exactly what we have, right? So we did the right thing. Yeah, pretty cool. Nice. Okay. It's tangent. Just kidding. I'm just kidding. All right. Does that make sense, Anthony? I'll do the second question too. If the second submission you have. It does. Yeah, it does relate to electricity and sound waves. Yeah. Derivatives are everywhere. Okay. All right, I'm gonna save that one, Anthony, for you. So I'll put this also in our Discord, and then we'll look at the next one you have. So that'll show up right here. And then I'm going to drag the screenshot in for you, so you have a copy of it. Who submitted Putnam questions? I'm guessing it's Val. Val wants to test you, Naroski. We'll do that after Anthony's here. Our Putnam question, they're competition questions, right? We're talking about this one. Yeah, this is gonna be tricky. I might just have Narowski like teach this one to me. Okay, let's see what the other one was. Okay. Ooh, what do you want me to... You had it on a number theory exam. Ooh, okay. Narowski, have you taken number theory? Or is number theory like just like real analysis? You hate it? Yeah. I used to hate it, and I'm starting to learn to like it because eventually people are showing me how to do it. You hate algebra? Okay. This was submitted as just a screenshot of something. Determine the first derivative. Okay, cool. Perfect. Yeah, we can do that for sure. Couple ways. So you could treat this as a product rule. Sorry, as a quotient rule. See how you have something divided by something? Could do it as a quotient rule. Although I think the better way to do this is to distribute this to both sides. And then do two separate integrals. Because a plus b over c is the same thing as a over c plus b over c. And then this way we don't have to do any crazy quotient rule stuff. It's just all power rule. So if I do this over this, I'm going to get 5 over 2. And then I don't like square roots. So I'm going to write that as an exponent. So square root is to the 1/2 power. So this is x to the 3rd to the 1/2 over x, right? So this is the 2x from here. And then this is plus 7x squared over 2x, right? This simplifies really nicely, right? This is already just going to be 7/2 x, right? X squared over x. One of them cancels. Here, so if you have x to the 3rd to the 1/2, exponents to exponents multiply. So that's 5/2 x to the 3/2 over x to the 1st, which then 3/2 minus 1 is going to get you 5/2 x to the 1/2. And now this is a much easier to take a derivative of, Anthony, right? Because all I got to do is take this, bring it down, so that's going to become 5/4, and then I drop the power by 1. So that's going to be 5/4 x to the negative 1/2. Then this is just going to be plus 7/2. And then if you want to write this nicely, this is 5/4. 5 over 4 square root of x, I guess, plus 7 over 2. Technically, this is correct. Your teacher might be mad and wants you to write it as, like, one fraction. So, in that case, you need to multiply... let's see. This would have to be multiplied by 2 over square root of x on both sides, on top and bottom. So then you'd get 5 plus 14 root x all over 4 root x. And then I guess your final thing is to multiply top and bottom by root x. So that would give you 5 root x plus 14 x all over 4x. Yeah. Maybe that's like the safest way to write it. I think so. We can also, here, just for... I want to see what chat would do. It's always fun to see what the AI clankers think. Yeah, okay. Yep, did the same thing. Did the same thing here. Took the derivative. Yep, and that's what I got, right? 5 over 4 square root of x. Yeah, but what if we say, like, my teacher is really picky about formatting the final answer. What would be a safe response so I do not incur her wrath? Teacher proofing the answer. I love they call it teacher proofing. I think it's more digestible too, but here we go. Ultra safe alternate form if she likes a simple fraction. This is kind of what I was talking about. Oh wait, well that was that. So yes. Here, we can be even more funny. I could be like but yes, but no surds in the denominator. A classic hidden boss fight. Chat's getting like kind of wait. Okay, whatever. Okay. Whatever. Okay. This is just semantics at this point. Yeah. I think this is okay. Just you can submit it this way. Just do that. Or yeah, if you really wanted to, you could also do this as 5 root x over 4x plus 7 halves. I think. Yeah. Okay. And this is a lot easier than, again, you could have done the quotient rule. So the derivative of the top times the bottom minus the derivative of the bottom times the top over the bottom squared. But man, that would suck. You really don't want to do that. This is the hack. Makes it a lot easier to deal with. Cool. Nice, Anthony.
Well done. Well done.
All right, let's see. V Sigma has a Putnam question. Can I go understand Eric's real quick? I want to see what you guys did with that one. This one right here that I was like absolutely like struggling on.
You done messed up, Aaron.
Let's like put it further down. And then let me see what you submitted. V Sigma. Copy this image in. Oh, all right. Okay. So a sub n plus 1 was the same as 1 plus the product. Wait, what was it called? It's not called product sum, right? I'm not allowed to call it product sum. Okay, just product, right? Okay. The product from I equals 1 to little n of a sub I. Okay, so I agree with that. So then what you did is you re-indexed this. Is that kind of what's happening here? You're saying, oh, a sub n plus 1 is equal to this. So then a sub n. So in my mind, I think of this as like saying, oh, well, let n equal like u minus 1. So then this is a sub u. And this is 1 to the... And then this is u minus 1. But it still starts at 1. Okay. I agree. Cool. And then you squared it. All right, so you square this. A sub n squared. And, yeah, this is just like a... Or, sorry, you don't square it, sorry. You're multiplying it by a sub n. Okay. Which is giving you a sub n gets multiplied in here, and then you have... Interesting. Why does this turn to I equals 1 to n of a sub n? Why is that? Oh, because a sub n is the last term. Got you. Oh, I see what's happening. Oh, that's very clever, actually. Okay. I think I see. Yes, the initial product stopped at a sub n minus 1. Right, exactly. So then you multiplied by a sub n. That's beautiful. Oh, that's really cool. Yeah, I need to get... That's a trick that I've seen. It's a technique I've seen a couple times now. I need to get better at recognizing that. Where, okay, yeah. If this gets multiplied by the nth term, now this sum doesn't go to n minus 1. It goes to n. And now it incorporates it. I see. Very cool. And so I would say that if this was a sum instead of a product, then I would want to add a sub n maybe. Right? In order to bump the thing up. Very cool. Okay. I think it's fun to see like techniques, like what would I do in this case? What would I do in this case? Okay, very cool. So now you have a sub n squared in a lot of stuff here going. Okay, cool. So then this is a sub n. Okay, sorry, it's the product of a sub n, which equals a sub n. But then, oh, this whole thing is equal to this again. Oh, okay, is equal to a sub n plus 1 minus 1. Man, that's so trippy. That's cool. So you're really just you're just like fucking around with indices. 1 plus 1, please.
Good job.
2, or I think it's 3 if you're Terrence Howard. Ryan says, I'm about halfway done with all the trig functions I have to write to automate my job. Oh, okay. What's your job in trig functions? I'm glad I stopped to catch the live. This is so much better than 4 days straight of 10 hours of trig. Yeah. Tell me about it. Wait, what's your job involve? How are you automating your job with trig functions? Tell the class, please, Ryan. I'm curious. Okay. Very cool. 2 plus 1, please. Wow, now you're getting demanding. Okay. So this is really cool. Okay, so I see. So this is now this. Brilliant. Okay, great. So then a sub n squared minus a sub n is equal to a sub n plus 1 plus minus 1. And then you factor out a sub n. Okay. And you get that. Okay, so... Oh. Very cool. Okay, wait. So then the last term here, 1 over a sub n minus 1, is the same thing as... Okay, I think I see what's happening here. All the reindexing is so fun. Yes, okay, got you. Let m plus 1 equal to n. Wait. Yes, okay. So then this... Okay, so big N minus 1 is equal to little n. Okay, so now this becomes big N minus 1. Crazy. Okay, which is equal to... Wait, what? How do we get to this? Let's see, sorry. Is this partial fractions you're just doing? Mm-hmm. Oh, okay, cool. Okay, so yeah, so this is a trick. This is something you just memorized. What's up, Marcelo? 9 plus 1 is equal to 10. So I could say this is partial fractions. But maybe that's one I should learn. Yeah, 1 over k minus 1 is equal to 1 over k minus 1 over k. Well, I know I could verify it, right? I could multiply this by k over k. And then this is k minus 1. And then k minus 1 gets plus 1. Yeah, okay, cool. So let's put this in our toolbox. I say we should know this one. Remember. Cool trick. Ryan says, I'm manufacturing design and process engineer for a multinational retail fixture manufacturer. I'm currently on a high-profile retail contract worth $60 million. That was 100% manual when I started. Oh, dear.
Surprise, motherfucker.
I imagine with AI these days, can't you just get Claudebot to just, like, code your job? Bruck says, I usually whip out heaviside cover-up method for partial fraction decomposition. Oh, that's where, like, oh, I remember. You cover this and you're like, oh, let k equal 1. What does the other one equal? Let k equal 0. What does the other one equal? Yeah. I think, is that the cover-up method you guys are talking about? Like, ugh. Ah, okay. That's cool, Ryan. Let's hope retail, like, stays alive. I think maybe the cover-up method he's talking about is this. So you know this is equal to, like, A over K plus B. Or, sorry, A over K minus 1 plus B over K. And then, like, you multiply both things through. So then you get 1 is equal to K times A plus K minus 1 times B. And then I guess the cover-up method is, oh, if K equals 1, well, then this goes away. If K equals 1, then A equals 1. Bingo. And then if K equals 0, this goes away. And then you get, oh, K must also equal 0. No, K must equal 2? Wait a minute. Wow, thanks, Shaq. Appreciate the bits, dude. Thanks, dog. Sorry, wait. K equals 0. Am I crazy? Oh, yeah, 1 equals negative B. Oh, I'm dumb.
Oh, shit. Not
So then B is negative 1. Okay, cool. Yes. Is that the cover-up method you talk about? I think that's what it is. Did you know you can use the money from Twitch to convert them into bits? Yes, I do know that. Yeah, you can choose to not get paid.
surprise, motherfucker.
You can just use the money they give you to spend more money on Twitch. That's how they... Okay. Heave-aside cover-up method. Yeah, wait, what? Yo. Yeah, see, this is... Okay. Oh, and then he shows how to do it for quadratic factors. Mm-hmm. Right, okay, where you cancel out one of them. Okay. This is cool. I appreciate it, Shaq. Thanks for the $1. You're a G, dude.
Good job.
Okay. All right, so wait, all right, let's go back to this. So I got the partial fractions. Love that. And then I say... Oh, I don't know why this arrow's going up, but okay. You're writing everything in Lisp. The client isn't... Oh, yeah, okay.
Good job.
So it's like T-Mobile or Verizon or something. Yeah, they have a bunch of retail stores, yeah. For sure. What is Lisp? Is Lisp a language? Wait. Lisp was developed in the 1950s? Wait, really? I don't even think I've even heard of this language. Wow. I mean, I know about like Fortran and stuff. List processing. Damn. These dudes are old. Dude, see, yeah. Okay, here we go. Here we go. Scheme in the 1970s. Right? Okay. Where do I understand coding? Well, actually, none of this. Oh, these are dialects of Lisp. Oh. Fortran was only a little bit before. Oh, that's cool. This is like apparently a Lisp machine. Artificial intelligence. Wow. This is cool. Anyways. Okay. Very cool, dude. Okay. All right. Partial fractions. So then you have 1 over n minus 1, a n minus 1, 1 plus a n minus 1, blah, 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 all the way to that is equal to one is equal to this. Okay, minus n minus 1. Oh, I see. And so you show that this one always cancels out with the next one. So it's telescoping. Uh-huh. Yes, it's sum reversed. Okay, I got you. Right. Because this is the sum we're trying to compute. And what you showed is that this is equal to 1 over, what do we say? 1 over a n minus 1 minus 1. And then minus 1 over a n minus 1. Uh-huh. Or sorry, that's just what this term is equal to. Oh, that's cool. Major AI, another AI boom 50 years ago? Wow.
Bing, bing, bang.
I see. So that one cancels. Okay, but where does the other one go then? That's the last term. Yeah, you start. I see. Your strategy would start with the last term because it's so weird. Okay. And then, okay, so that's what the last term is equal to. But then, are you plugging it into the next? So I understand how this one becomes this, right? And then this one will cancel off this one. But then what about the ones in between? Why does n minus 2 get canceled off as well? Because the next one that would survive, right, would be 1 a. You have an arrow there. Dun, 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 dun. Oh. Okay, okay, I think I see what you're saying. You're saying that this one is the same thing as this. Okay, great. Yes, yes, yes. Okay, I understand that. And then, oh, that expands out again. Oh, I see. So then you have 1 over a big N minus 2, right? Uh-huh. Minus, all right, big N minus 2 minus 1. Then minus 1 over a n minus 2. Right, okay. And then this one will cancel off this one. I see. So this just like keeps going. Oh, that's cool. Because then I can rewrite this one as products from this, and then I can partial fractions it out again. And so it keeps killing things off. Okay, so how do you know when it stops killing things? Right? At what point does it stop? Yeah, n minus 3, n minus 4. I guess it can't go negative, right? Yeah, because eventually one of them has to survive. I see. So once you get to here... No, oh, because the concept of the sum to exist is for n is greater than or equal to 2. How do we know big N is greater than or equal to 2, by the way? Sorry. Or, okay, N is greater than or equal to 3. How do we know that? Oh, is it because this one doesn't have a minus 1 on it anymore? Got you. Mm-hmm. Wow. Yeah, this is such a mindfuck. This is cool, Eric. I see. It does not make any sense to go from A1, A2, and then A1 minus 1. Yeah. Right, because then that would be A0. That doesn't work. I see. These two have to survive. Right, okay. Yes. Well, big N is equal to 4, I guess, right? Oh, wait, no. I see what you're saying, sorry. It's very weird that it does not put an interior limit for N. Yeah. Okay, so then you're left with this. And then, right, yeah, we said A2 was equal to a half. We found that out earlier, right? Didn't I figure that out earlier? Yeah. Wait a minute. Wait. 1 over A2 minus 1 plus 1 over A1. A1 was equal to 2. But wait, wasn't A2 equal to 1? Sorry, wasn't A2 equal to 2? I think that's what we found out, right? This is 1/2. Then A... Yeah, it was equal to 3. Yeah, right? Yeah, okay. Wait. Ugh. A2 was equal to 1 plus 1, which is equal to 2. Right, oh, it was equal to 1/3. Okay. Yeah, and then, sorry, this was A2, right? It was equal to 3. Oh, yes. Okay, so then it's 3 minus 1, which is 2. 1/2 plus 1/2. Okay, final answer is 1. Okay, great. Wow. Thank you, Val. I really appreciate this. This was cool. I learned. I don't think I would have been able to get this on my own. I very much needed the help of chat for this one, and I appreciate it, Val. Yeah, there were a couple cool... I think this technique of multiplying through by a sub n and then re-indexing, that was really cool. And then doing some more fun re-indexing tricks to try to write it as a telescoping series. And then partial fractions. And then... Oh, I would have gotten lost here as well. It makes sense to me. Cool. All right. Thank you. I appreciate that. Yeah, that was fun. Yeah. I know most of the kids looking at this like, what? It's not very fun. I think it's fun to be challenged, though. Yes. How'd you find us, Val, by the way? We was just randomly just scrolling through TikTok. And you just said, oh, someone's doing a really hard math question from Eric. Eric's the guy who submitted that question. He's another streamer, actually, as well. And so, I'll invite, yeah, if you guys are watching. Maps. We love maps, right? Yeah. Let me shout out Eric. Yeah. You can also go to this website, the same website where people are submitting screenshots. If you click on the streaming schedule, I saw this random problem I like to solve. Oh, that's cool. Oh, yeah. Well, if you want to ever, like, join more streams of just, not only me. We have a lot of other really cool people that stream. The link where you upload things, there's also a link to the streaming schedule. You can see that these are all the other awesome streamers that do things. So Eric, who came up with the question, is actually going to do abstract algebra tomorrow at 2 o'clock, my time, Pacific. So whatever time that is in your time zone, you can go check him out. He's cool. Math Pond is doing some stuff as well. Math Pond's been doing some cool lessons. And then Zach, who was here earlier, Either2iPie, will be live on Saturday morning. And we'll be playing chess on Friday. Okay, let me see what the other ones were. I have 15 minutes before I gotta go. And maybe tonight. Ooh, I look forward to it, Eric. Yeah, make sure, go follow Eric so you get a notification to it. Right now, it's 5 a.m. I didn't sleep because I have an exam. Oh, good luck in statistics. I actually like statistics. I think statistics is cool. I'm bored to keep studying. Yeah, well, you found the right place. Let me see if I can do this one. Sleep, please. Yeah, you need sleep. Sleep is important. And then, Willie, my Nilly, I see you have a physics question, actually. This is a cool one. I might not have time to do this one, Willie, but this is fun. I know these questions. I think the setup for this... Sorry, let me just show Willie real quick what the setup is for it. Work is equal to the integral of, like, f dx. Okay? Which is equal to... do they... Oh, they do give you the... They give you... This is a density, by the way. And then, so the force is equal to mg, which, in this case, you have to write that m is equal to, like, a volume. Let me think. Okay, so m is equal to rho dv is what this is. And then times g. And then dx is, like, the height that you're moving it, per se. So the dx is the distance from, like, your mass element to the top. So I think in this case, let me just show what that would be. And what they say. Oh, and there's a spout. Why'd they do that? There's a spout as well. And they put a spout on this thing? Man, that's kind of annoying. It's okay. It's just an additional +2 you gotta deal with. Okay, because then this is the water spout. Okay, so you have to, like, set an axis that you want to do things from. Gotta set something equal to 0. I don't know. Maybe call this y equals 0. Call this this is y equals 3, right? And then this is, like, y equals 5, I guess, right? So work would be equal to the integral. So the force is going to be rho dv times g, and then times the distance you have to bring it up. So what you usually do is you think about, if I had, like, a slice of mass right here that I was trying to, like, bring up, right? Let's say we were, like, looking at this. Say this was, like, dv. The volume of that would be equal to some thickness dy, and then it would be equal to whatever this, like, width is, and then times the length, which the length is 8. So here, let me show you this. And then this is 8. So you would say that dv is equal to 8w dy, right? That describes the volume of this slab. And then the distance you have to move it to, which is, like, dx. That describes what this distance is. And so, and actually, maybe I should call this, like, should call this delta x. Because the force is not going to change depending on the... Well, actually, I guess it does. But the magnitude of the force doesn't change. So it's like delta x. Or let's call it, like, delta height. And so delta height, that's equal to, so let's say you're at some position y, then the distance you have to take that mass and get it through the spout would be 5 minus whatever y is. Yeah, that's okay, yeah. So this is where you have to move this mass. You have to move it up to there. And so the distance you have to move it is equal to 5 minus y. Right? So you get that work is equal to the integral. So whatever, calculate rho. Rho is 62.5. I think in this case, I think G is equal to 32 then. For like foot-pounds or something. I think G is equal to 32. I think G is equal to 32 in these weird-ass units. Okay, so rho is equal to 62.5. G is equal to 32. And so then it's rho, G, and then this is now 5 minus Y. And then dV is going to be width. So 8W dy. And then you got to think about like, okay, but when I'm looking at my mass, my dV, what y values am I going to traverse? Well, the mass only exists from 0 to 3. So that's why this integral only integrates over mass that's located from 0 to 3. Because once you get up to like 5, now there's no longer any mass.
No.
Right? Now, so this is why this integral goes from 0 to 3. And then I think the final thing is you have to express w in terms of y. Which this is a right triangle. This is a similar triangles thing, right? So in this case, do they tell you the width of it? Yeah. Okay. Oh, it's an equilateral triangle. Okay. So 3 over 3. Oh, okay. So 3 over 3 is equal to W over Y. That's actually really, really convenient. So Y equals W. Oh, yeah. Right? I think that works. Yeah. Okay. So this is your final integral. 0 to 3, I think this is 62.5. And then this is 32. And then it's 5 minus y times 8y dy. And then just do the integral. Yeah. I think that's what it is. So I'll leave that to you to actually do it. If the tank is a sphere, would I set the origin in the center? Ooh, I forget. Yeah, no, I think you can. Yeah, surface areas where you can't do this. Yeah, I think you can approximate this as a bunch of disks, right? I think you can say this is pi r squared dy, right? And then there's a relationship between r and y. So you could set this equal to the origin, but then you got to be careful because your integral is going to have to go from like a negative r to positive r, right? And you got to make sure this won't lead to having like negative volumes. I guess it's pi r squared, so you're okay. Yeah. Right? Because I think in this case, dV is equal to pi r squared dy, right? And so, yeah, you can go from negative r to positive r. And then you need the relationship of y and r, which... How does that relate? So depending on, like, what your distance is here, what is this? It wouldn't be double the integral from 0 to r because moving mass, Val, from the bottom half has to travel a greater distance than mass from the top half. Yeah, so work is always related to force, which is rho dvg. Yes, so this will be symmetric. The issue is the height won't. It takes more work to move this chunk up to here than it takes to move this chunk up to here. And then you have to add the fucking +1, dude. That's so annoying. Okay, if you call this equal to 0, then x squared plus y squared would be equal to 9. I'm trying. You need a relationship. Sorry for r as a function. It's not a triangle though, right? It's like this. Need a relationship for what this is compared to this. Oh, I think I get it. I think I get it. Okay. Okay. The radius. What's up, Alistair?
My man.
So wait one sec. Draw this out as like a circle. Sometimes it just helps. Right? And let's pretend this is like y equals 0. Because you eventually need to know what this is. Which is, yes, okay, got it. This right here, this is like your r prime. Because dv is going to be equal to pi r prime squared dy, right? And then r prime needs to be a function of y, because you're going to integrate from like -3 to +3. Right? This is -3, this is +3. And so, okay, yeah, go to Twitch. So then, this is the equation of a circle. This is x squared plus y squared, and right, r prime is the same thing as just x. X squared plus y squared is equal to 9. So then x is equal to the square root of 9 minus y squared. So there you go. And then this is equal to r prime. Okay. So your dv term is equal to pi, and then this is r prime squared. So this is going to be 9 minus y squared dy. So then, and then you're going to integrate this from -3 to 3. And that's going to be rho g this and then the height. So the height it has to move is equal to I think it's 4 minus y. Right? So let's think, right? If your y is equal to 3, then you only have to move another 1. So that makes sense, right? 4 minus 3 should be 1. And then if your y is equal to -3, then technically you should have to run to 7. And 4 minus 3 is 7.
Good
Okay, there you go. Yeah, this is it. I think for the sphere. Does that make sense? Willie? It's kind of a crazy question. Oh, but I've seen him before. I know I have. Okay, cool. All right, nice. Helped a lot. Awesome. I'm going to put that on our Discord. Are you in our Discord, Willie? I'll put the screenshot to this in there. And then the other cool thing is nowadays it'll also show the YouTube link to when that happened as well. All right, nice. Okay, cool. Just comment on it, and so you also get credit for it as well. So here, I'll put that in right here. Cool. Thank you for your help and your time, good sir. Thank you. Appreciate it. That's cool. Okay. Shit, I'm out of time. How about this? Val, thank you for finding us, by the way. Do you want to? We can do this during the next stream. Or also, I'll put it in our Discord anyways, and then that way, if Zach or one of them wants to take a shot at it, they can as well. Yeah, it's super fun. I appreciate you submitting it. Apparently, it's a Putnam question. He says, is what Narosky said. So this one might be a little tough. But sequences and primes and stuff, and all this divisibility stuff. Wow, this is crazy. Okay, cool. All right, let's close out the stream. All right, awesome. Thank you everyone for you just got the number? Okay. We'll check it then. Thank you everyone for coming by the stream. Yes, appreciate it. Thanks for if you found us through any of the other platforms, welcome. We stream 4 times a week, doing all sorts of fun stuff. So make sure go to the website actualofficehours.com and you can follow us on Twitch and YouTube, join our Discord. Really cool community of people we got there who some people are really geniuses at math. Some people are just passionate about learning. Some people just hate math. We welcome everybody, and we want to like help you guys out in the ways that we can. So, that being said, our next stream for homework stuff will be on Sunday. But if you want to come play chess with us, we're going to do a tournament tomorrow. That will be on the calendar. I'll make an announcement in the Discord as well. So if you join the Discord, and especially if you choose the chess player role, you'll get notified about it. So let's see. But let's go raid somebody cool. Who's doing a bunch of stuff today? Eric, you're about to stream. Let's go say hi to you. We're going to go say hi to Eric. Eric's great. Okay. Enjoy the rest of your week. We'll see you for chess on Friday. If not, we'll see you on Sunday. Peace.